So a linear chord is a chord which is closed under addition of words. So that is a linear chord. But linear chord എന്ന് പറഞ്ഞാൽ a chord C is closed under addition. അതിനെയാണ് നമ്മൾ linear chord എന്ന് പറയുന്നത്. So here ഇവിടെ ഒരു examples തന്നിട്ടുണ്ട്. C is equal to 0, 0, 0, 1, 1, 1 is a linear chord. Linear chord എന്നാണ് question. അപ്പോൾ നമ്മൾ എന്താ പറയുന്നത്? What is a linear chord? For every V and W, V plus W is in V. അതായിരിക്കണം നമ്മളുടെ linear chord definition. So here 0, 0. അപ്പോൾ first നമ്മൾ 0, 0 plus 0, 0 കാണാം. That is 0, 0, which belongs to the set C. And 0, 0 plus 1, 1, which is equal to 1, 1 is belongs to this one. And 1, 1 plus 0, 0. ഇത് നമ്മൾ കൺസിഡർ ചെയ്യണം കേട്ടോ, കാരണം ബിക്കോസ് വി ഇസ് 0, 0 പ്ലസ് 1, 1 വാട്ട് ഇവിടെ വി എന്ന് പറയുന്നത് 0, 0 ആണ് ആൻഡ് ഡബ്ല്യു ഇസ് 1, 1 ആണ്. ഹിയർ വി ഇസ് 1, 1 ആൻഡ് ഡബ്ല്യു ഇസ് 0, 0. സോ ബോത്ത് കേസസ് കൺസിഡർ ചെയ്യണം. സോ വി പ്ലസ് ഡബ്ല്യു ഇസ് നോട്ട് ഇസ് ഡബ്ല്യു എന്ന് സമേഷൻ വാല്യൂ സെയിം ആണ്. ബട്ട് ഈ ഒരു പ്രോപ്പർട്ടി നമ്മൾ പ്രോബബിലിറ്റിയിലാണെങ്കിലും, സോ പ്രോബബിലിറ്റിയിൽ നമ്മൾ എങ്ങനെ കൺസിഡർ ചെയ്യുന്നു? എച്ച് tail constraint and tail H. So first choice is head, second choice is tail. Another one, first choice is tail and second one is head. So നമ്മൾ ഈ രണ്ട് പോസിബിലിറ്റീസും കൺസിഡർ ചെയ്യുന്നുണ്ട്. സോ സിമിലർലി നമ്മൾ ഇവിടെയും അതുപോലെ തന്നെ കൺസിഡർ ചെയ്യണം. ആൻഡ് 1, 1 plus 1, 1 which is equal to 0. So 0, 0, 1, 1 which belongs to the set C. So C is a linear chord. So next we consider C1. 0, 0, 0, 0, 1, 1, 0, 1. So here 0, 0, 1 plus 1, 0, 1. That is what? 0 plus 1 is 1. 0 plus 0, 0. 1 plus 1, 0. So 100. 1, 0, 0. So it doesn't belong to the set C1. So C1 is not a linear chord. Clear? So this is the linear chord. A linear chord C must contain the 0 word. എപ്പോഴും linear chord പറയുന്നത് എന്താണ്? 0 വേർഡിനെ കണ്ടെയ്ൻ ചെയ്യും. So always a linear, നമ്മളൊക്കെ അറിയാം, വെക്ടർ സ്പേസ് ഓൾവേസ് എന്താണ്? വെക്ടർ സ്പേസിൽ 0 is the identity. So every vector space contain 0 ആണ്. Contain 0 ആണ്. So here similarly linear chord is also contain 0 word. Okay. For if it is said to be linear, then the sum V plus V is equal to 0 must be in C by closure under addition. However, as the chord C1 above the okay. So this is the linear chord concept. Next exercise ആണ്. So you do this have okay. ഇത് assignment work ആയിട്ട് consider ചെയ്യാം. You can do. So okay. So you can do the assignment problems. Marking C, D and G, H. So these are the assignment problems. Okay. So first one, okay, 1, 0, 1, 1, 1, 0, 1, 1. 1, 0, 1 plus 1, 0, 1 endu varum. That is 0, 0. So doesn't belongs to the set this one. So C is not a linear chord. So this is the linear chord. And the next one, this is the result. The distance of a linear chord is equal to the minimum weight of any non-zero chord word. Distance of a linear chord, that is D of VW, which is equal to minimum weight of a non-zero. A non-zero, let V be the non-zero. That weight is least weight. Okay, so that both of them are equal. So exercise ആണ്. Show that C is equal to is a linear chord and that is its distance is D. So find this question. And 2.1.4 I give the proof. Okay. Here 1 to 5 are the just advantage of linear chord. Linear chords in the advantages ആണ്. First one, for a linear chord there is a procedure for MLD that is simpler and faster to use than the one described earlier. Next, second one is encoding a linear chord is faster. It's very faster and require less storage space than for arbitrarily non-linear chords. And the probability theta P or CV is a straightforward to calculate. So easy to calculate. And fourth one is it is easy to describe the set of error pattern that a linear chord will detect. So linear chord എന്ത് ചെയ്യും? Error pattern detect ചെയ്യും. So linear chord detect the error pattern. And fifth one is it is much easier to describe the set of error patterns a linear chord will correct than it is for arbitrarily non-linear chords. Okay, here just ഒന്ന് സ്റ്റഡി ചെയ്ത് വെക്കുക കേട്ടോ. 5 advantages of linear chord ആണ്. The most important tool and technique for studying linear chords comes from linear algebra. So usually നമ്മൾ linear chord എന്ന ചാപ്റ്ററിൽ മെയിൻലി നമ്മൾ linear algebrയുടെ കോൺസെപ്റ്റ്സും ടേംസുകളാണ് യൂസ് ചെയ്യുന്നത്. ഓക്കെ, സോ നെക്സ്റ്റ് വൺ ഓൾറെഡി ഞാൻ പറഞ്ഞ കാര്യങ്ങൾ തന്നെയാണ്. Consisting of scalar k and set of vectors of word k raised to n together with the operations of vector addition and scalar multiplication. So already defined ആണ്, which is satisfy the 10 properties listed in. So നമ്മൾ first chapter we discussed 10 properties. Okay, so a non-empty subset U of a vector space V is a subspace of V if U is closed under vector addition and scalar multiplication. That is, if V and W are in U, then V plus W and AV are in U for any scalar A. In particular, since the only scalars in K are 0 and 1, U is a subspace of Kn if and only if U is closed under addition. Therefore, C is a linear chord if and only if C is a subspace of Kn. Clear? So, what is that? So let U be the subset of a V is said to be subspace. What is a subspace? Subspace vanathananda itself it is a vector space argument mean linear algebra. So here similarly U is a subset of V is said to be subspace. Then for every V and W in U, then എന്താണ് V plus W belongs to U തന്നെ ആയിരിക്കണം. That is U is closed under vector addition and scalar multiplication. Okay, and therefore U is a subspace of Kn means if and only if എന്തായിരിക്കും U is closed under addition. Addition കേസിൽ എന്തായിരിക്കും closed ആയിരിക്കും. Then closed under addition പറഞ്ഞാൽ തന്നെ that is linear chord. So the C is a linear chord if and only C എന്തായിരിക്കും K ന്റെ subspace. So C is a subspace of K. Okay, so that is the closed under addition. So രണ്ട് elements for every V and W ലും V plus W in belongs to the set C ആണെങ്കിൽ that set is closed under addition. So itself it is a linear chord and it is a subspace of K raised to n. Okay, so this is the subspace and two important subspace. Okay, next നമ്മൾ എന്താണ് linear combinations. Similarly, the vector W is said to be linear combinations of vectors v1, v2, etc. vk if there are scalars a1, a2, etc. ak such that W is equal to a1, v1 plus a2, v2 plus etc. plus ak, vk. The set of all linear combinations of the vectors in a given set S is equal to v1, v2, etc. vk is called the linear span of S and is denoted by a group S set spanned by S. If S is empty, we define a set is spanned span of S that is equal to singleton 0. Okay, so what is a linear combination? What? W is a linear combination of the vector v1, v2, etc. vk. That means there exists scalars a1, a2, etc. ak such that W is equal to as a linear combination of v1, v2, etc. vk. Okay, then W in the form. And the set of all linear combinations of the vectors in the given set S. So, if W is equal to, so W1 is also some linear combinations of v1, v2, etc. vk anengil. So, collection of all the set, collection of all the vectors, which is the linear combinations of v1, v2, etc. vk is called a linear span of S. That means a set is generated by the set is generated by the elements of the set S. So span S means similarly same concept then. So span S means that is denoted by a set, this one. So it's a collection of all vectors V such that W is equal to some A1, V2, etc. AK, VK. So collection of all vectors W, which is the linear combinations of V1, V2, etc. VK. So that is the linear span. So next, the linear span S is a subspace of, usually the subspace are generally the subspace are vector space in the subspace are. So here is a subspace of K raised to N. Okay. Since span S is a subspace in K raised to N, that is a span S is a linear chord generated by S. So span S means it is the linear chord. Is a linear chord as generated by what? S. Okay. So this is the span S. So next theorem. You can see. Okay. For any subset S of K raised to N, the chord C is equal to span S generated by S consists precisely of the following words: the zero word, all words in S, and all sums of two or more words in S. So what is theorem? C is equal to, C is a chord. Okay, C is a chord which is equal to a span S generated by S. So adil endokku undavum? Zero word must ആണ്. നമ്മൾ പറഞ്ഞു every linear chord must contain the zero word ആണ്. So must be എന്തുണ്ടാവും? Zero word ഉണ്ടാവും. All words in S and all sums of two or more words in S. Okay. So S is equal to some V1, V2, V3 ആണ് consider ചെയ്യുക. And C is the chord which is set generated by S. So must be എന്തുണ്ടാക്കണം? 0, 0. So left here just 0 consider ചെയ്യുക. 0 is the zero word of length 2 ആണെങ്കിൽ that is 0, 0. Of length 3 ആണെങ്കിൽ 0, 0. Okay. അപ്പോൾ 0. 0 is the zero word. And V1, V2, V3. So next എന്താണ്? V1 plus V2 ഉണ്ടാവും. V2 plus V3 ഉണ്ടാവും. V1 plus V3 and V1 plus V2 plus V3. So that is the set span S. So span S means must contain zero word and all the words V1, V2, V3 and their sum. So V1 plus V2, V1 plus V3, V2 plus V3. Also V1 plus V2 plus V3. So 3 ആണ് in the span S എന്ന് പറയുന്നത്. Okay. So here is an example. S is equal to 0, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0. And then the chord C is equal to this one generated by S. അപ്പോൾ first നമുക്ക് എന്തുണ്ടാവും? 0, 0, 0 must of length 4 അല്ലേ? അപ്പോൾ 0, 0, 0 0 word must contain and 0, 1, 0, 0 0, 0, 1, 1 1, 1, 0, 0. There's some first two 0, 0, 1, 0, 0, 0, 0, 1 this. And also here V1 plus V1 ഉണ്ടാവും. അതുപോലെ V2 plus V2 ഉണ്ടാവും. And also V3 plus V3. Okay. P3 sets ഉണ്ടാവും സ്പാനസിൽ. So 0, 1, 0, 0, 0, 0, 1, 1, 0, 1, 0, 0 this one, 0, 0 this one. Okay. 3 elements. Wait. Oh, sorry. Okay. V1 plus V1. V1 plus V1 means what? So here consider first element 0, 1, 0, 0 plus 0, 1, 0, 0 clearly 0 word. Okay. So adum included ആണ്. Okay. So this is the example of the above theorem. So here some exercise you must do it. Okay. Next step. V is equal to A1, A2, etc. An and W is equal to B1, B2, etc. Bn are vectors in Kn. We define the scalar product or dot product V dot W of V and W. That is, so here V is equal to A1, A2, etc. An and W is equal to B1, B2, etc. Bn. Then scalar product അല്ലെങ്കിൽ or dot product. So that is define A1, A2 etc. an dot B1 B2 etc. Bn. So that is equal to, similarly dot product define ചെയ്യുന്ന പോലെ തന്നെ A1 B1 plus A2 B2 plus etc. plus an Bn. So that is the dot product of two words. Okay. So here example 11001 dot 01101 which is equal to 10. That is 1 into 0. 1 into 0 plus 1 1. 1 into 1 plus 0 1. 0 into 1 plus 0 0. 0 into 0 plus 1 into 1. 1 into 1 which is equal to 1 0. Here 0 0. So that is 1 plus 1 which is equal to 0. So their dot product equal to 0. Okay. So here the construct here. This is the assignment problem 2.2.4. Okay. U dot ഇതുപോലെ കൺസിഡർ ചെയ്യാൻ മതി. So V is equal to A1 E2 etc. an and W is equal to B1 B2 etc. Bn and U is equal to some C1 C2 etc. Cn. So verify these two conditions. Okay. So this is the assignment problem. And the next V and W are orthogonal. Similarly നമ്മൾ linear algebra concepts തന്നെയാണ്. If a two vector that dot product equal to 0 means that two vectors are orthogonal to each other. So similarly vectors V and W, vectors means words, okay, so code word which belongs to set C aanikku. So V and W are orthogonal if V dot W equal to 0. Okay. So above example 11001 dot 011 dot 1 that is equal to 0. So these two vectors are orthogonal in have length 5 LS. So in k raised to 5. Okay. So for a given set S of vectors in Kn, we say a vector V is orthogonal to the set S if V dot W is equal to 0 for all V in for all W in S that is V is orthogonal to every vector in S. So the set of all vectors orthogonal to S is denoted by S per. Usually നമ്മൾ denote ചെയ്യുന്നില്ലേ same തന്നെ S per and is called the orthogonal complement. So S per is means, what is S per? It is the set of all vectors orthogonal to S. That is a set of all V such that V dot S per is a set of all vectors orthogonal to S. That is set of all V such that V dot W is equal to 0 for every W belongs to S. So this is the S per. S per is also subspace of what? K raised to n. That is called orthogonal complement of S. Okay. So that is denoted by S per. S per is a subspace of V. So S per is a subspace of K raised to n. Okay. If C is equal to span S, then we write C per is equal to S per and C per is a dual chord of C. So if C is equal to, so C is set generated by S ആണെങ്കിൽ then C per is equal to എന്തായിരിക്കും? S per. C per is equal to S per and C per is called dual chord of C. Dual chord of C. So here S is equal to 0100 0101. We compute the dual chord C per which is equal to S per. We must find all words V is equal to this one is X, Y, Z, W on it. Okay. Of length K4. Okay. Such that both the equations V dot 0100 equal to 0, V dot 0101 which is equal to 0. So what is this? S is equal to, here S is equal to set S is equal to set 0, 1, 0, 0, 0, 1, 0, 1. This is a set S. And V is the form X, Y, Z, W in K raised to 4. So, both the equations satisfy ചെയ്യുന്ന V ന്റെ collections ആണ് ചോദിക്കുന്നത്. So, here V dot 0, 1, 0, 0 equal to 0. That implies V is X, Y, Z, W dot X, Y, Z, W dot 0, 1, 0, 0. Which is equal to X into 0. X into 0 plus Y into 1 equal to 0 implies on it. Okay. So, X into 0 plus Y into 1 plus Z into 0 plus W into 0 which is equal to what? Y. So, Y equal to 0. So, Y must be 0. And V dot 0, 1, 0. 0, 1, 0, 1 which is equal to 0 implies X, Y, Z, W dot 0, 1, 0, 1 which is equal to 0 implies what? X into 0 plus Y into 1 plus Z into 0 plus W into 1 which is equal to 0. That is Y plus W. Y plus W equal to 0. Given Y is equal to 0. So, Y is equal to 0 implies W is equal to 0. So, Y and W are 0. Okay. So, possibilities of V ആണ് കേട്ടോ. അതായത് ഇവിടെ ക്വസ്റ്റ്യൻ എന്താ വെച്ചാൽ S is equal to 0, 1, 0, 0 യും 0, 1, 0, 1 നമുക്ക് തന്നിട്ടുണ്ട്. C pub is S pub ആണ്. So, what is S pub? It is a collection of all vectors V such that V dot W is equal to 0. Okay. So, collection of all V such that V dot 0, 1, 0, 0 equal to 0 and V dot 0, 1, 0, 1 which is equal to 0. We can find V. Possibilities of V's ആണ് ചോദിക്കുന്നത്. Okay, that is the question. What are the possibilities of V? Okay, so first equation V dot 0, 1, 0, 0 implies Y is equal to 0 and V dot 0, 1, 0 that is this one. V dot 0, 1, 0, 1 which is equal to 0 implies Y plus W is equal to 0. Here Y is equal to 0 then this implies W. So, Y and W എന്തായിരിക്കണം 0 ആയിരിക്കും. So, Y and W equal to 0. So, Y is equal to W is equal to 0. So, possibilities of X and Z are either 0 or 1. Okay. So, and the elements ഉണ്ടാവും. If X is equal to Z is equal to 0 consider. So, first element. So, S per possibility of V എന്തായിരിക്കണം 0, 0, Y set Y and W always 0 ആണ് 0, 0. So, this is 1V. So, which is 0, 0, 0 orthogonal to 0, 1, 0 and 0, 0, 1 ആണ്. Okay. So, this is true. So, next if X is equal to 0, Z is equal to 1. So, V must be എന്തായിരിക്കണം V is X, Y, Z, W. Okay. So, X is equal to 0. So, 0, Y is 0, Z is 1, W is 0. So, this is one possibility. Next, if X is equal to 1, Z is equal to 0. So, V is equal to what? 1, 0, Y 0, Z is 0 and W is 1. So, this is another possibility. If X is equal to 1, Z is equal to 1. So, V is equal to 1, 0, 1, 0. So, 4 possibilities of V. Therefore, S perb is what? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0. So, this is the S perb. Clear? So, നമ്മുടെ ക്വസ്റ്റ്യൻ എന്താണ് എസ് ഇസ് ഈക്വൽ ടു തന്നിട്ടുണ്ട് എസ് പെർബ് കാണണമെങ്കിൽ നമ്മൾ ഈ ഒരു പോസിബിലിറ്റീസ് വെച്ചിട്ട് വേണം വി ക്യാൻ ഫൈൻഡ്. So, this is the question. അതൊക്കെ ഇമ്പോർട്ടൻ്റ് ആണ്. ജസ്റ്റ് വെരിഫൈ വാട്ട് ഈസ് എസ് പെർബ് വിച്ച് ഇസ് ഈക്വൽ ടു എസ് പെർബ്. യൂഷ്വലി നമ്മൾ ലീനിയർ ആൾജിബ്ര കോൺസെപ്റ്റ്സ് തന്നെയാണ്. സോ യു ക്യാൻ ട്രൈ. നെക്സ്റ്റ് ഇൻഡിപെൻഡൻസ് ബേസിസ് ഡയമെൻഷൻ. ഓക്കെ, യൂഷ്വൽ നോട്ടേഷൻ തന്നെയാണ്. A set S a set S is equal to V1, V2, etc. Pk of vectors is linearly dependent, which means if there are scalars A1, A2, etc. Ak, not all 0. Linearly dependent means A1, A2, etc. Ak. Scalars are not 0 such that A1, V1 plus A2, V2 plus etc. plus Ak, Vk equal to 0. Otherwise, it is linearly independent. So, linearly independent means all the scalars must be equal to 0. Next, same thaniyana. If the other scalar A1, A2, etc. Ak to be 0, then the set S is linearly independent. If at least one A1 can be chosen to be non-zero, then S is linearly independent. So, if A2, A3, etc. equal to 0 and A1 not equal to 0, that set sorry, linearly dependent. Okay, so here some example. This one 2.3.1. So S is equal to 1 0 0 1 1 1 0 1 1 0 1 1. So we consider A, B, C are the scalars. Then their linear combination, that is A into 1 0 0 1 plus B into 1 1 0 1 plus C into 1 0 1 1, which is equal to 0 0. So we get the equations A plus B plus C equal to 0. That is A, B, C. Okay. So A plus B plus C equal to 0. B is equal to 0. C is equal to 0. If B and C is equal to 0, A must be equal to 0. So A equal to B equal to C equal to 0. Therefore, this set is linearly independent. Similarly, we can verify this example also. Okay. Consider first two equations, then consider other two equations and 1 and 3. So we get the three equations given A and B and C and 1 and the possibilities. Okay, so you can read. And any set of vector S not equal to singleton 0 contain a largest linearly independent subset. Any vector, any set of vector non-zero containing ഏതൊരു സെറ്റ് എടുത്താലും എന്തായിരിക്കും non-zero linearly independent subsets contain ചെയ്യും. Okay, so this is the example of linearly dependent. Okay, and here are some questions, so you can verify it is whether it is linearly independent or dependent. Okay, so next, any set of vectors containing the zero vector is linearly. Usually definition then a set which one, this one, last one, this contain a zero vector. Okay, so this set must be linearly dependent. Okay, another definition, a non-empty subset B, a non-empty subset B of vectors from a vector space V is a basis for V if both B spans V, that is span of B is equal to V, and B is linearly independent set. So consider B is a set which spans V and also B is linearly independent, then B is said to be what? Basis. Okay, so this is the example. Here some examples are, so you can read. Similarly, similar exams are type of discuss either. Okay. So next, in general, a vector space usually have many bases. We already linear algebra concepts are a vector space has not unique. Vector space in another level unique basis and vector space have many bases and examples. So here S is the set and B 1 1 0 0 1 1 1 1 is not is the basis and B1 is also basis. So any set, any vector space have more than one basis. Okay, the number of elements in vector space contain this. The number of elements in any basis for any vector space is called the dimension of the vector, dimension of the space. Okay, so basis we already parnu B is the basis of a vector space V ആണെങ്കിൽ a number of elements in the basis, that is the dimension of the vector space. Okay. So here dimension of Kn is n. Since the set of all words of length n and weight 1 is, weight already 1 ആയിരിക്കും, least weight ആണ് consider ചെയ്യുക കേട്ടോ, as a basis for Kn. So singleton 0. A set has dimension always 0 ആയിരിക്കും. So next എന്താ പറയുന്നത്, a basis for any vector space V, if V1, V2, etc. Vk is a basis for V, then every vector W in V can be expressed as a unique linear combination of the basis vectors V1, V2, etc. Vk. That is, there exists a unique scalars A1, A2, etc. Ak such as W is equal to A1, V1 plus A2, V2 plus etc. Ak, Vk. Okay, so here, so V is a vector space and V1, V2, etc. Vk. Okay, Vk is the basis for V ആണെങ്കിൽ for every vector W in V, W is a linear combination of V1, V2, etc. Vk ആയിരിക്കും. Clear? So this is the vector dimension and also basis. Okay, here some exercises ആണ്, questions ആണ് ട്ടോ. And the theorems next class we discuss.